Hi there, I'm Andrew Pardo. I'm back like an inconsistent repro. I'm here now to talk about .NET Native, deep dive into that. I hope you're enjoying the conference. I really enjoyed Larry's session. You know, working as I do at the bottom of the stack, it's nice to see people actually put things like universal apps to use. I've got a couple of emails on here. You should note the .NET Native at Microsoft.com. That actually gets to some key members of the .NET Native team, and is a quicker way to get your questions answered than sending me mail, although you're always welcome to send me mail. Again, if you have questions, the .NET blog is a great place to look. If you see here, what I've done is I've searched for tags that says .NET Native. We tag all of our blog posts, so if you search for the .NET Native tag, you'll actually get all of the .NET Native blog posts, and this list goes way, way down the screen. We've got a ton of blog posts on there about .NET Native. So, back into .NET code generation. Apologies if you saw this slide earlier. .NET code starts as source code, C# source code, VB source code, F# source code. You may know that .NET Native currently is limited to C#, but that's just because we're trying to change things in Microsoft. We're trying to change how we do things. And one of the changes we're making is to try to release products early so that we can get your feedback instead of waiting until stuff is baked. So we started with C#, we started with Windows Store. We started with Windows Store because it's a smaller profile, easier to target, and also Windows Store apps are pretty awesome. So .NET code generation. You start with C# source code, VB source code. You compile it with a compiler such as Roslyn. You end up with MSIL bytecode. MSIL bytecode is where my team comes in. This is the Microsoft Intermediate language. It's a stack-based language, which is an abstract representation, an abstract machine representation of your program. You generate code in some fashion, and that code that you've generated is machine code. So x86 or AMD 64 or ARM machine code, depending on what computer you're running on or phone. Code generation can be done either lazily at runtime, which is what you do with a JIT, or optimistically at build time or at install time. And .NET Native, all of our code generation is optimistic. So .NET code execution today. Currently in the big .NET framework, we've got a JIT and NGen, which is built upon the JIT. So the JIT does the lazy code compilation, and NGen does the optimistic install time code compilation. .NET kind of sits right there in the middle and sort of spans out to both experiences. If you need the better performance that you can get from pre-compilation or the lack of the JIT compile time at your app startup, then you can run NGen. If you need the JIT compilation, the dynamic experience, then you can JIT your app or JIT methods in your app if it's NGen. What we're doing with .NET Native is we're trying to hit one end of that spectrum really hard. We're really trying to get the C++-like performance and the deployment characteristics of self-contained apps without giving up on the dynamic experience, the unlimited class libraries, all of the productivity features that make people love to use .NET. So as I was saying, in code generation in CLR 4.5, we've got a couple of JIT compilers. I talked a little bit about this in my first talk, and we are investing in our JIT compilers with ReuJIT. So we are definitely not going all native, all static. .NET there's many scenarios we need to satisfy. We're making sure to hit all of them. And we've got the one runtime or virtual execution engine which spans these multiple scenarios. And one thing that's important to realize is that the desktop CLR that works for Windows clients, server workloads, it's actually the same code base as the core CLR that we use for mobile scenarios or for some targeted server workloads like the cloud optimized .NET that's out with ASP.NET vNext. So I mentioned earlier about Triton. .NET Native is really an evolution of Triton, so I'm going to talk a little bit about what Triton was. NGen, Triton is built upon NGen, and NGen is a tool that allows you to natively compile your applications from MSIL into machine assembly language, x86 ASM or ARM ASM, and you do this at install time. Now, there's different ways to do this with NGen. When we install the .NET framework, we create native images with NGen for all of the .NET framework libraries. If you install an app, such as Visual Studio, When Visual Studio is installed, at install time, they take the time to do NGen, and that gets you performance improvements given that you don't have to JIT all of Visual Studio as you try to start it. So we definitely wanted the benefits of NGen for Windows Phone. But what we didn't want was for people to be compiling code on their phones, because once you stick a compiler in your pocket, you're going to end up with a burn on your thigh. So what we did was we came up with something called MDIL, a machine-dependent intermediate language. Whereas MSIL is based upon a stack machine, MDIL is pretty much assembly code for any given architecture with a few fix-ups that are left up to be fixed up on the user's phone. So in Windows Phone, if you write a Windows Phone app, you as the developer write C# code and you upload your app as MSIL into the Windows Phone store. In the cloud, we convert MSIL into MDIL. And this is the first half of NGen. This is the part where we're allocating registers, we're doing optimizations like common sub-expression elimination, our data flow optimizations, all of the things that make compilers smart. We do all of this work in the cloud so that the user doesn't have to do that on their phone. But we don't know what version of the framework the user has on his or her device. If you have a Windows Phone, you'll know that the updates come through the phone's carrier. And so if you've got an AT&T device, you might have a slightly different version than if you have a T-Mobile device or an O2 device. And so we don't know a priori which version of the framework you have installed on your phone, so we can't completely compile to native. Because once you compile an app to native, you've taken dependencies on things that depend upon the framework, such as what assembly does System Console write line live in? Well, on the phone, I guess you don't have System Console write line, but I'm kind of a bottom of the stack guy. Where do I find this API? What is the shape of this runtime data structure? These things change slightly from version to version. Even though there's no behavior difference, there are some dependencies taken by native images. So with Triton, we do the hard compilation in the cloud and then the easy bit on the user's phone. And .NET Native builds upon that. So we're going to talk about some different properties of code execution or code generation in this talk. Code generation, you've got throughput and code quality and memory usage. .NET Native takes care of the throughput problem by not doing any code generation when you run the app. The user downloads and runs a native app. The code quality, our code is compiled by the C++ optimizer, and the memory usage we've also made some improvements on, as you'll see. There are deployment properties. How do you distribute your app? We talked a little bit earlier about the difference between the big .NET framework that's installed with Windows and NuGet, where the libraries are now being distributed through NuGet so that the developer can choose the version. So distribution format is definitely, there are some trade-offs there as to whether you like the C++ native distribution format where all of your libraries come along, and that's what .NET Native does, or whether you like the big .NET framework distribution format where you just push around your app and all the libraries are installed on the machine. Distribution talks about, that brings into question the acquisition process. How does the user get the app? If you're running a .NET Native app, the entire runtime comes with the app. Whereas if you're running a .NET app, you need to have it installed on your machine or you need to install .NET. You may have tried to run a .NET 3.5 app on a Windows 8 machine and seen that you get a dialog coming up saying, hey, we need to install .NET 3.5. Security properties, type-safe execution is something that we will not give up on. We certainly believe on the .NET team that type safety not only gives you developer productivity, it also gives you safer apps. Like one of the best ways to fix a security bug is not to write it in the first place. Code identity, isolation, security functionality, whether you get that from the platform or the app. And then the developer experience. One thing that's absolutely true is that everything in engineering is a trade-off. So what we tried to do with .NET Native, and I'm stealing this one from Larry Wall, the genius who created Perl, one of my favorite programming languages, we really tried to make simple things easy while making the hard things possible. So where we're going with .NET code execution, .NET code generation. As I said earlier, from the one side, we're coming in with .NET Native to give you the C# productivity with the C++ performance. On the other side, we are investing in a new JIT, our new ReUJIT, and many changes in the CLR VM. If you saw my earlier talk, all the changes we pushed out with .NET 4.5. there are many experiences that are purely dynamic experiences, which still demand that we innovate on the dynamic space as well as in the precompiled. So whereas today we have one runtime engine and the same code execution, code generators for all scenarios, and tomorrow we've got refactored engines. We've got our cloud-optimized .NET native, server SKUs, desktop SKUs, all of these things built from a common core, really delivering best of class on both sides. Right now we're focusing on the outsides, but from there we can help to improve the middle as we bring .NET Native to other scenarios. So let's dive a little into .NET Native. And I don't see any questions yet. I'm not sure if the question feed is working or if I haven't gotten any questions. I'll assume that you are doing the right thing. So .NET Native. .NET Native is a new pre-compilation story for Windows Store apps that allows you to generate native applications, fully self-contained, and what your user downloads from the Windows Store is the complete app package, including the runtime, the GC, everything is there. There's a few apps, thank you, here's a question. There are a few apps that are in the Windows Store today using .NET Native. We haven't opened up .NET Native for uploads broadly. We are curating who can upload, but we wanted to prove to ourselves that the entire pipeline works. We've got a couple of Microsoft apps. Fresh Paint was our first, and then Wordament is an awesome game. And then we partnered with the Discovery Channel to bring in 3 of their apps. There's a question from Vishal about what exactly is MSIL to MDIL over the cloud. So if we go back, I'm actually going to flip back in my slides. I know you're not supposed to do that, but if you go back to code generation, something has to, so a C# compiler, Roslyn, or whatever your language compiler happens to be, takes your app from source code into MSIL. And MSIL, when it's an accurate representation of your program, but it's not ready for any machine to run. It's based on an abstract stack machine. You need to turn that code into real assembly code for any particular architecture like ARM or x86. And so the question is, how do you get from the MSIL to machine code? With Windows Phone, we introduced a concept of MDIL, that is a machine-dependent intermediate language. MDIL is still an intermediate language because it's not an actual runnable application at this point, but it's machine-dependent. So if you were to take a Windows Phone application in the store as it is, before it gets downloaded to the user's device and bound into an actual functional application, what you would see is a stream of ARM assembly code and then a number of fix-ups. And these fix-ups allow us to say, hey, this API is located in that DLL and that's over here. We might even say this API is at offset hex 4324 in assembly foo. And so the MSIL to MDIL is the conversion. This is the hard compilation bit that we can do in the cloud. And then the MDIL to a native executable we do on Windows Phone. All right, back to .NET Native. So .NET Native is our compiler in the cloud for store apps. As I've said, I have said that it represents an evolution of Triton and NGen. It uses a very lean runtime. The runtime actually gets distributed with the application, and the VC++ optimizer so that you get fast code execution with less memory usage. It provides a converged developer experience across devices. Currently, we're just targeting Windows Store, but we plan on bringing this out across many scenarios. Here are some performance numbers that we're seeing on Wordament. It's a real-world app, a game in Windows Store today. 30 to 40% startup wins, depending on whether it's a cold or a warm start, and 12% memory usage decrease. I'm going to go ahead a little bit before getting to your questions. I do see them there. Thank you. The Visual Studio experience for .NET Native is as simple as it could be. You go to our site, you download .NET Native. It is a package that installs on top of Visual Studio. Once that's installed, you just enable .NET Native for your project. You'll get a report that tells you anything you should watch out for, and then you debug, test your app with .NET Native. Everything should work, but as I said, we are releasing things early so that we can get your feedback, see what works, see what doesn't work. We really appreciate your feedback at the .NET Native alias. From ASP, is .NET Native's performance as good as C++? ASP, I would love to have an apples-to-apples comparison. I would love to see an app that is written in both .NET Native and C++. One of the problems that we have in the compiler world is the best we can do is apples-to-apple juice. Fresh Paint was written in C++ in Windows 8. They converted a good portion of it to C# in Windows 8.1. The benefit of converting to C# is that they were able to do a lot more. If you use Fresh Paint, you'll see that they've added a bunch of great functionality around buying add-on packs, picture packs, just new things that you can do with the app. All of this code, it is our belief that .NET is a more productive language to develop in than C++. And so in converting their app from C++ to C#, they were able to add a bunch of functionality. Now the question is about performance. Is the performance as good as C++ performance? Well, their app is faster in 8.1, written with C#, compiled with .NET Native, than it was in 8.0. But it's not a fair comparison because anytime you rewrite an app, you're going to make improvements in your architecture. So we've tried to do some comparison between apples-to-apples comparisons for C++ and C#. There are some Visual Studio samples that we've compiled, but unfortunately there's only so much you can do. Is it as good as C++? I'm going to say just about. There are some things we do better. There are many things that C++ does better. Fresh Paint is a great example. They've got an awesome alpha blending engine inside of their app. I'm pretty certain that that code is still written in C++, and I'm not arguing with that choice. But as far as the productive code with C++ like performance, C# was really the best choice. From another question, when will we be able to use .NET Native for C#, WPF, and WinForms apps? The best I can tell you is in the future. We are not yet finished with the Windows Store version. Is .NET Native only for ARM, or is it also for x86 and x64? With our CTP3 that came out at or around TechEd, we added x64. No, actually, we had x64 support in our build release. We added x86. But point is, you can use it for any version of the Windows Store. If you are on an ARM tablet or an x86 or an x64 app, you can use .NET Native. Any plans for .NET for Windows Phone instead of MDIL? Actually, that question's cut off right now. I'll get to that in a moment. I can see the end. But I'll get back to that question, Dennis. I'm going to jump into the .NET Native compiler toolchain. Here we go. I would prefer to have the same technology for Windows Phone and Windows Store. Dennis, I agree. I would prefer to have the same technology for Windows Phone and Windows Store. Part of this is an accident of time. Like Windows Phone really had to have a cloud-based compile when Windows Phone 8 released and we moved from .NET Compact Framework over to Core CLR. Triton was what we could deliver at that point. .NET Native builds upon Triton. We're definitely going to bring it to Windows Phone. I can't commit to timelines for that in this talk, but yes, we will be using .NET Native on Windows Phone as well as in Windows Store. And then Tom Atwood, when will .NET Native be available for desktop server apps? Again, it's definitely on our radar. I can't make promises as to dates now. Right now, we are working with the curated API surfaces. So, Windows Store, there's a limited number of APIs that are available when you compare it to, say, WPF or the full desktop, any of the stacks that you can bring in there. So diving into the toolchain. So this is basically the slide I showed earlier about C# compilation and native code gen, but this dives a bunch deeper into what happens in that middle box. So as always, you start with C# source code, and right now it is C#, although there's nothing about .NET Native that limits it to C#. You use your C# compiler, and you end up with an MSIL application. This you could jet and run the minute that you want to. One of the things that we do with .NET Native is we need to right now we've limited ourselves to only static code generation. That again is not something that's necessary for .NET Native, but it's a decision that we've made so that we can really target the static scenario and bring that to a first-class experience instead of targeting the middle and kind of stretch towards static. So we're doing everything statically right now. You may be familiar with sgen, the serialization generator. It creates a static representation of your serialization code. This is available for desktop apps and or server apps, and we brought this into the .NET Native toolchain. It generates C# code for your serialization that we can compile rather than having this had to be done at runtime. sgen is an awesome tool, and so we decided the other place that we could use this capability is in interop code. And this gets to Dan Fisher's question. Thank you for setting me up, Dan. Are there any perf improvements or gains for .NET Native code, for native code interop? So all of the interop, most of the interop in Windows Store is WinRT interop, but what we did was we created a marshalling code generator. The marshalling code generator is very similar to the serialization generator. It takes your interop code and it gives you C# code. Then we can compile both the serialization code and your interop code with the C# compiler, giving you serialization DLLs that can now be compiled into your .NET Native app. One of the advantages of pre-generated interop code, sorry, the braces make it very difficult to talk, is that your interop code is generated as MSIL at runtime in the big .NET. So it gets JIT compiled into machine code, executed, and then thrown out. If you end up with a problem in your pinvoke signature, which is quite a common thing, it's really hard to debug through the assembly code because that's all that you have to work with. In .NET Native, one of the huge advantages of the marshalling code generator is that you get your interop code as a C# file. When you want to step through that code, you're stepping through C#, not assembly. You can also, if you like, rip apart that code, inspect it, optimize it before it gets compiled to MSIL. Going back to some questions from Marco. Why .NET Native setup is just for VS 2013 Ultimate? Is there a plan for a Pro version? I'll beat your Pro, I'll give you an Express. As I said, we try to release things early to get some feedback. It was easiest for us to target VS 2013 Ultimate. We actually plan on targeting the next version of Visual Studio, and I guess I don't actually know the real name for the next version. I'll just say Visual Studio vNext. We're planning on targeting Visual Studio vNext when we release .NET Native, and we plan on targeting all the SKUs of Visual Studio vNext, Express, Pro, Ultimate, whatever we release. But with Visual Studio 2013, we kept it scoped. We focused on bringing the compiler tool chain up instead of worrying about how we were going to get Express and how we were going to get everything else. I will defer this question for just a few minutes and move on with the slides. The IL compiler. So at this point, we have your application, which is MSIL, and we have your interop DLL and your serialization DLL. So all of the code that most of the code that we would be generating at runtime on the big .NET are generated as C# code and compiled into DLLs. We then take the .NET framework libraries that you depend upon, as well as any of the DLLs, the managed DLLs and the managed WinMDs. We merge all of this into one big application. And the reason that we do this is, if you're old enough, you'll remember the rule tar before gzip, that if you put all of your files into one big tarball before you run gzip on them, then gzip has the largest window that it can use to pack your code into the smallest possible package. This is what we're doing here. We really want the optimizers to have the largest scope to work on, so that by doing this, we can inline from here to here to here, which we've never been able to do if these were separate assemblies. But then you've got this huge app. It contains all of your .NET framework dependencies. Obviously, if you're calling something in system collections like ArrayList, the one thing I know in system collections, if you're calling one method on ArrayList, you don't want to bring in all of the different types in system collections. You really just want an array list. In fact, you just want that one method and whatever types you're using. So we have a dependency reducer that throws away, it tree shakes and throws away all of the things that you're not using, so that now you end up with a reduced merged app, which is an MSIL application that works perfectly, could be JITted with the JIT compiler, and has with it all of the .NET framework code that you are referencing. So, one of the problems that we are generating static dynamic code. You know, one of the huge developer productivity things about .NET is that you can do things statically. You can reflect. You can, say, hey, I've got this type. I want to do something with this type. Maybe I want to serialize this type. Maybe I want to deserialize this type. I need to know what it is. What do I call this thing? What do I call the members inside of this type? You use reflection to do this. You say, what is my type? What are its members? What is this named? Is there a name matching this? This is really hard to do statically, because you have always done this at runtime with reflection, and you know what questions to ask, and all of your metadata is there. So we end up with a bit of a conundrum. Static compilation means that any code that can run has been generated at compile time. But reflection and many of the dynamic capabilities of .NET mean that anything you can look at runtime, anything you can do at runtime can be executed. So the solution is, when we do that app reduction where we get rid of metadata you're not using, get rid of types you're not using, and code you're not using, we need to preserve the set of classes, methods, generic types, metadata. We need to preserve all the stuff that your code might want to call. And if we get it wrong, you get an exception. And you please file a bug with our team. Now, I'm going to let you think about that for a minute as I get to some more of the questions. Does .NET Native work in the cloud as well, or on the client machine? If it runs in the cloud, does it produce some kind of MDIL which gets compiled to native on the end user machine? So .NET Native, in Visual Studio, you go through the whole native compilation so that you can debug your app as your user would run it on the device. You can do performance measurements as your user would use it. But when you upload to the store, you upload MSIL, we compile in the cloud, and then your user downloads that fully compiled native app. There's one more question here? Not yet. All right, so the question is, how do we know to preserve the runtime metadata when we're doing all the compilation statically? Well, we have something in .NET Native that we're calling runtime directives. This is XML because everything is XML. It is neither compact nor human readable, but we all love it. XML, we have this RDXML that says, is a set of runtime directives that says this is the metadata, these are the types that we need to preserve for the application. And this is the default, where if you create a .NET Native app, the big change you'll see right now is that this gets added to your project. The line that you're interested in here is assembly name application star dynamic is required all. Question from Raleigh, whether I have any talks or demos that will show how to use debug tools at the MSIL level. That's out of scope for this talk, sorry. And I'll get to that next question in a bit. So, first section of this line is the assembly name application star application. This is actually a magic keyword that breaks out of the rules I'm going to explain in a minute. Application star application means all the types in the app assembly, so code that you, as the developer, wrote for your app. This is the type specification. This says the class, the namespace, the assembly, what's the scope that this particular directive line should address. And the types can be classes, interfaces, structs. You can have groups of types like namespace or this magic thing here, application star application. Or you can go down to type members, methods, fields, properties, events. Dynamic here is what we call the degree. And the degree tells the compiler what behavior is needed. You can actually see in here that the way that we talk about these things reflects the fact that we worked on this over and over trying to get it right. We really would appreciate your feedback on knowing how we did. We think we ended up with a good balance of usability and correctness here, or usability while keeping it correct. The degree tells the compiler what behavior is needed. There's different kinds of behavior. For example, serialization behavior, interop behaviors. Dynamic means you can execute code on any of these types. Then the last is the policy. It notes the scope to which that behavior is applied to things inside of that type. And so the scope is simple, like all public, private, internal. These are the things that you know from C# coding, C++ coding. There's another keyword here, required. Required is another magic word, and required, in addition to public or private or internal, tells the compiler toolchain, please include these types in the final binary. Do not reduce them when you get rid of them. Now, before I go back to the toolchain, I'm going to look at a few questions. Enrique, should we use .NET Native for all apps going forward? Any reasons why not to use .NET Native? Yes, there are reasons not to use .NET Native. .NET Native, currently it's only available for store apps. It's optimized for store apps. We can re-optimize it for other scenarios. When we bring this to cloud scenarios, when we bring this to desktop scenarios, then .NET Native is obviously a great choice. There are many things that you can only do dynamically. The JIT compiler is there. We're investing in the JIT because dynamic code generation is valuable and useful and will always have some advantages that static compilation doesn't have. For example, regit is useful for application attached when you're doing profiling. There's code DOM. You are never, code DOM is where you have your application put out C# code. Your C# code gets compiled into MSIL during runtime, and then your code is JITted and executed. You will never get code DOM working with static compilation. It just doesn't work. Plans for native with .NET Micro framework so we can better compete with other devices. Keep your eye on what the IoT team is saying this year. Andre, does merging mean that I will have one pretty big executable without any DLLs? I'll get to that in a minute. Let me actually go ahead with that. So the last step is going from MSIL to MDIL to machine code. So you've got your merged app, and then you compile this into an MDIL app. We are using MDIL from Triton. It was a useful abstraction for us, although it's not a necessary abstraction in .NET Native because we're doing the compilation all the way down to native code. So we actually use, this compiler here is the C++ optimizer, and this is nice because we can share optimizations with the C++ team as they bring them online for .NET Native. And then binding, which is also done in the store as opposed to Triton where it's done in the, on the user's device, binding produces an application that works. So in response to your question, you end up with an app DLL, which is all of your app's code. It is machine code, so ARM assembly or x86 assembly, and all of your libraries are in there. Everything is in there, everything that you have referenced, all of your interop code, all of your serialization code. You end up with an app exe. This is just a stub loader. A Windows Store app is an executable, and so we have a loader that says, hey, just call this app DLL. And then we've got MRT app DLL. This is the runtime. This is the entire runtime. Yes, I can wrap up in 5 minutes. Let me see. This is the runtime, and this gets distributed with your app. While this work in incorporating class libraries in the compilation, the concept of dynamic link libraries works quite well. Yes, it does, but it's nice that the optimizer can work over the entire scope. We have talked about shared libraries with .NET Native. There's nothing preventing us from bringing in shared libraries, but currently we are doing the tar the whole thing in, optimize it, produce a single app binary, and we like the results we've seen with that. I mentioned that we could bring in C++ optimizations. We had an amusing blog post, or comment on a blog post where we were talking about this great performance. We've been focusing on startup performance because for store apps, that's really is that's where the big wins are. You want to make sure that when you start a store app that it starts quickly because that's where the responsiveness matters. And they're usually very simple apps that aren't doing a bunch of things. So the long-running app, you don't need the code quality for the long-running app execution. But somebody posted on the blog post and said, hey, I've got this ray tracer sample that's written in C++ and C#, and .NET Native does not do very well. So we wrote a response, talked about how we were focusing on store apps and startup was the big win, et cetera, et cetera, et cetera. But we thought we should give this to the C++ folks to give a chance to look at our comment because we didn't want to diss them on the blog, right? I mean, they're all our friends. We all work together. And the C++ developer lead was like, well, this ray tracer, it relies on vectorization and parallelization, and we can turn on automatic vectorization and parallelization. Just give me a couple of weeks to do it. And so he took this C++ optimization that they just brought in the last few years for C++, turned it on for .NET Native, and boom, it's there. All of a sudden, the ray tracer worked almost as fast as the C++ version. Now, all of the optimizations that the C++ optimizer does right now are not enabled for .NET Native, but as we bring this up online, we're going to enable these optimizations in .NET Native. And then as the C++ team does their new work, brings in new innovative optimizations, they'll be just coming online automatically for .NET Native. So some of the performance gains that we're seeing from .NET Native, I've talked a little bit about it, but just to go over again, we have an optimized runtime, very small, distributed with the app. We have refactored library codes. Sorry, slides go this way. Our libraries have been refactored, optimized for static, only bring in the things that are needed. We've got pre-generated interop code, pre-generated serialization code. Any work that doesn't have to be done at runtime will obviously bring you a performance increase at runtime. We tree shake the code. We throw away what you don't need. You end up with some fantastic size benefits from, if you're using .NET on an end-to-end application and you're calling ArrayList, you're getting all of system collections or whatever assembly ArrayList lives in pulled into your application. Whereas with .NET Native, we're throwing away the rest of system collections if you're not using it, as an example. And so your memory impact is only from what the code you're actually calling. And we actually have it so that we can end up with more shareable pages. Pay-for-play metadata with the RDXML, you say what to bring in, what not to bring in. Usually people are focused about bringing in everything they need for their app to run correctly. But you can also, if you want to super optimize your app, and we have a blog post about this, you can pull out things that aren't used if you know you can get rid of them. Then there's the C++ optimizer working globally across the entire app. The whole tar before bin, the merge your app before you optimize it, get the best global optimizations working across the entire application scope. Finish up with a call to action. AKAMS.NET Native is our page. There is the blog with the .NET tag. Download the tools. Currently, we're Visual Studio 2013. We will move ahead with Visual Studio. If you have if you have any app, please try it out. If you don't have an app, now's the time to write one. If you have a top store app, or if you have a library, especially, please send us mail. We want to hear from you. We want to work with some of the top apps. We want to work with popular libraries. We have a forum for .NET Native, and of course, you can always send us email. You can tweet us, email us, Facebook us, user voice us, blah, 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 blah. It's been great talking to you all. Thank you much, and my time is up.